Okay, so welcome to 721. We're just going to run through some very simple stuff in multi-sim. We're going to run, we're going to introduce how to put the basic components onto the drawing area. We're going to run some very, very simple simulations using multimeters. And then finally we're going to do an AC sweep across the entire range and produce a bow plot. Okay, so Mike, if you can just point that at the screen and I'll just make a start here for everyone. Okay, you got it? Mm-hmm. Brilliant. Right, so I shut this down. So you want multi-sim 14, so you go down to the box at the bottom. I'm going to go through this fairly quickly, one because we're videoing it, and two because there's not so many of you here today, so we can probably give you more personal assistance as well. So multi-sim 14, open her up, and there is multi-sim 14. Right, the first thing I want to do here is I want to construct one of these, which is a potential divider. So a very, very simple kind of circuit here, potential divider. Sorry, Mike's got a... Well, it's alright, Mike, because we were going to have it on the video screen in a minute, but...
Potential divider.
A potential divider, which takes some of the current and puts it down to ground, and takes some of the current and puts it on the output. We'll see how useful a circuit that is in a minute. It's a really, really powerful thing to have an understanding of. Okay, multi-sim's a complicated thing. Let's just learn by example. So the first thing I want to do inside multi-sim is I want to place a component. So I'm going to go up here. Look, watching what I'm doing. You copy me word for word, letter for letter, action for action. So up the top there, go to place, component. Okay, you've got that open. Hope so. And if you look down here where it says group, you'll see that there's a category called basic. Open up basic, scroll down till you see the word resistor, click on it, then click OK, and you should have a resistor on the end of your cursor. Tell me if you can't do that. Tell Mike if you can't do that, because I'm not going to move something basic.
Everybody happy? Yeah. Resistor, multi-sim. Like a resistor. We've got to do today. How are you? You happy? In front of the screen, happy? You understand everything? Yeah. You can see, did you do this last time? Yeah. So this time you can do the other side. Come and have a look at this side. Last time you did the pulse filter, yes? So John said to the digital challenge today, so you can do a high pass filter.
Yeah, so do what you did yesterday, but do it with the high pass.
Yeah, this was the one you did yesterday. So today, can you do that one?
Okay, so those of you remaining, okay, so we're going to put the resistor down. How do we put the resistor down? We left click, and suddenly it appears. This window comes back again, but cancel it, just close it, and you'll see that your resistor is on the drawing area. Okay, Mark, you can sort them out. You put the resistor down in the drawing area, and you'll see that the default one is 1K. That's fine, that'll do it. 1K is okay. Not much of a circuit yet, so let's go back and place another component. You'll notice this time it's gone straight to resistor. Well, that's fine because I want a resistor. So I'm going to take the resistor and plonk it in the drawing area. It doesn't really matter where. And I'm going to close it. Okay, I'm assuming you've done that because you managed to do one, so I suspect you can probably do two. The next thing I want to be able to do The next thing I want to be able to do is I want to be able to rotate this component because I want it to look like the drawing that I had on the board. So first thing I do is I click on it, you notice a blue box has come around it, I right click and one of the options I have. Look, it's rotate 90 degrees clockwise. There we go. How neat is that? So that's starting to look like the circuit I had on the board now. Okay, the next thing I can do is I can let's wire something up. So if I take my cursor to the end of the connection, click on it, and go onto this connection, click on it, you'll notice there's a red wire between those two components. Can't do that, stick your hand in the air and we'll come rushing around and help you. I assume you can. Okay, just give me 30 seconds to reflect on that. Okay, the second resistor is 1K as well, exactly the same. Okay, so the next thing I want to do is I want to put in a power source. I need a V in, right? So this time I'm going to go to Plates, Component, and this time I'm going to go up to where it says Basic, and you'll see I've got all of these options down here, and one of them is Sources. That doesn't mean tomato ketchup or brown sauce or whatever, but go to Sources, click on Sources, and you'll see I've got lots and lots of different options here, but the one I want actually is, where is it? DC power, which is basically a battery, okay? So that's under Sources, DC power. I'll leave that on the screen just for a few seconds. Have they all found it, Mike? It looks like they have. Okay, looks good. So now we're going to click OK because we want that to come up. So we plop that into the drawing area where we want it. Just close that for the minute. I was saying to the gang yesterday, 12 volts, I don't like 12 volts, I like 10 volts. I like things to be in chunks of tens and zeros.
So 10 volts and 1 power 100 volts.
Yeah. So I double click on my battery and I'm going to change the value in there from 12 volts to 10 volts and say OK. You'll notice it's changed in the drawing, what I wanted. Yeah, all got that. I can see, the ones I can see, they've all got it. And I can't see anybody frantically waving their arms, so I think everything is OK. So now I want to wire the battery up to the resistor at the top there. Well, we know how to do that. We click on one end, and then we get this wild piece of string on the end, and we're going to click onto the resistor, and it's wired up. Yeah. So far, so good. Now we want to make a connection from here over to the other resistor here, and I can do that in exactly the same way as I did before. We've now got a closed loop. That is a circuit. That's an odd thing about a circuit. You must have closed loops. And that's the first circuit we've designed in multi-sim. Pretty useless because we're not doing any measurements yet. We've got a power supply source in there. And surprisingly, if we go up to the top here, can you see where that green triangle is, where my cursor is? If I click on that green triangle and run it, the simulation's perfectly happy to run. It's a bit like a program with no print statements, so we're not getting any output because we haven't asked for any output. So we're going to stop the simulation. Now, what could we use to do a measurement with? We could use a multimeter, voltmeter, ammeter, oscilloscope, lots and lots of different things. But if we go over to this far right hand side, look, can you see where my cursor is? Right over on the far right hand side. Yeah? There's a load of little buttons over here. The top button, if I hover over the top button, it says multimeter, right? And if I click on that and come across to my drawing, look what I've got. I've got a thing, but it's meant to be a multimeter. So I'll put that where I want it to be, click, and it's come into being. If I double click on it, you can see that I can see the readout from it. So at the moment it's set to volts, that's fine. And at the moment it's set to DC, this is AC here and this is DC here. At the moment it's set to DC, which is what we want. So we put that somewhere where it's convenient for us. Well, I'll put that here. I'm not using that part of the drawing here. Click away. Now I can join my multimeter to the output, and if you look at the circuit on the board, that's V out that I'm doing here, and I can connect that side to the ground. Right, now I've got a closed circuit, and I've got a measuring device attached to the closed circuit. Things are going to change now because we are going to see some results come out. So if I press the run button, look, 5 volts comes out on the multimeter. Isn't that marvellous? Is that what you expected to happen? Maybe, maybe not. Let's hit the stop button. Now let's change one of these values from 1K to 2K. So all I do is double click on it, go up to here, and I can change the value to 2K. Now the abbreviations you have are K for 1,000, little m for milli, which is 1,000, M for a million, capital M for a million. You'll get used to those kind of things, and a U for micro, all these kind of things. But at the moment we want, you could equally just write 2,000 there if you wanted to, rather than 2K. Now if I OK this, so notice I've got a 1K here and a 2K here. If I click the run now, lo and behold, I've got 6 2/3 volts coming out of my V out. Why have I? Because 2/3 of the voltage is dropped across R2. 1/3 is dropped across R1. Theory, don't worry about it, but it's just R2 upon R1 plus R2 is the equation which is defined here. Could I ask you, just for a couple of 3 minutes, to change these values around? So play with the value of R1, play with the value of R2, and see how that affects the voltage which is coming out of your multimeter. Okay? Make sure that all the drawing that you've done so far is okay. Now, there is just a footnote I would add here, that I'm amazed this works, because I forgot to do something which is absolutely critical in multisim, is that I didn't put a ground. So what